Hello everyone, welcome to free crash course for competitive exams held by Virat Hindustan Sangam in association with Manifest IAS Bengaluru. This program is inspired by Dr. Subramaniam Swamy and it is convened by Ravi Shankar Sir, State Education Convener for VHS Karnataka branch. So you can watch this program online on the YouTube channel of Virat Hindustan Sangam, also on the YouTube channel of Udaya News Karnataka. For any further queries, mentoring, guidance, you can contact us on our Telegram group VHS Education Forum. So I am the chief mentor of your program. So we are done with polity, history and economy and progressing towards the geographic section of your syllabus. Right? Let us begin the class. So we were talking about the interior of the earth. So interior of the earth, if you talk about the interior of the earth, if you take the cross section, it is actually like this. So first there will be inner core, then outer core, inner core, then you have mantle, inner mantle, outer mantle, in between you have asthenosphere, right? Over that you have crust, outer mantle, inner mantle. This is the asthenosphere, right? So your crust plus upper mantle is called as lithosphere, right? This lithosphere is the part for your plate tectonics, right? Upper mantle and the crust together constitutes a lithosphere which forms a plate. So we will today discuss what is plate tectonics, right? So yesterday we were talking about the earthquake waves, right? There are if an earthquake takes place, the point of earthquake is the focus and the exact point, nearest point on the surface of the earth is called epicenter. There are primarily two kinds of waves. One is body waves, the other is surface waves. In the body waves, you have primary waves and secondary waves. So this is a broad classification. So how does the earthquake waves travel? How does it propagate? Right? So it propagates. When it propagates, it causes vibration in the body of rocks. Whenever the earthquake waves travel through a rock, I told you, if there is a denser medium, the velocity will be higher. If the medium of the rock is, or medium of any material is not so dense, suppose air or water, then the velocity will be low. Also, there will be reflection and refraction with respect to the earthquake waves. So this causes vibration in the body of rocks. Whatever the body it goes through, it causes vibration, right? So these P waves, primary waves, they vibrate parallel to the direction of the wave. That is, if the wave is traveling in this direction, it will vibrate in the same direction like this, right? So what happens if it vibrates in the same direction of the wave? It will cause to stretching and squeezing, right? The body of the material through which the wave pass through, it stretches and then squeezes, right? So that will happen when the P waves travel, right? It vibrates parallel to the direction of the wave, right? This is the concept. And other waves, you take surface waves, you take S waves, they vibrate perpendicular. That is, if the direction of the wave is like this, they vibrate perpendicularly like this. So this is parallelly, this is perpendicularly. So you should know which waves vibrate perpendicularly and parallelly, right? Then you have the concept of shadow zone, right? Shadow zone, it is, how do you know there is what is shadow zone? See, let's say there is a earthquake here, right? So this is the epicenter, right? So you have, this is the core, right? So you have from the focus of the earth wave, the P waves and S wave travel in all the direction, right? Whereas they travel through core also, right? Like this. See, till 105 degree, from this point till 105 degree, both P waves and S wave will be received up to, from the epicenter up to see, if you take this as 0 degree, this is 90 degree, this is 105 degree. If you take up to 105 degrees, both P waves and S waves are received, right? Whereas from 105 to 145 degree, right? Till here, till this, only till here there will be no waves. In this space there will be no waves, right? Between 105 and 145 there will be no P waves and S waves, right? Whereas from 145 up to 180, again you find the P waves, right? So this will be on the both the direction. Here also P waves and S waves are received up to 105 degree. From 105 degree to 145 degree, there will be no waves coming, right? In this space it will be entirely blank, right? So this is called the shadow wave for both P waves and S waves. Whereas from 145 degree up to 180 degree, you receive P waves again, right? P waves again. However, S waves won't come here, right? So the shadow zone, see where the waves don't come, where the waves are not going to shown up on the other side of the earth, it is called shadow zone, right? So where here the shadow zone of S wave. So shadow zone of S wave is from 105 degree up to 180 degree. Whereas P wave shadow zone is only 105 to 145 degree. So the S wave shadow zone is bigger than the P wave shadow zone. The concept of shadow zone is very, very important, right? So these numbers you should remember, 105 degree and 145 degree. This is the concept. Next you have types of earthquake. What are the types of earthquake that are there on the planet Earth? So you have majorly what we see is tectonic earthquake. Tectonic earthquake is with respect to tectonic plates. What is plate? A plate is, so whatever the earth, continental mass and the continental earth as well as oceanic earth, we have crust plus lithosphere, right? Crust plus upper mantle. So this is lithosphere. This lithosphere constitutes one plate. It will be moving over the asthenosphere, right? So if there is a collision of plates, I will discuss what is plates. So if there is a collision of plates, what happens? There will be tectonic earthquake, right? So here there will be sliding of the rocks. There will be one plate and another plate, they are compressing and there will be friction and they slide. They give away and they will slide, right? That is the sliding of the rocks will constitute the tectonic earthquake, right? That is the first type of earthquake. Next you have volcanic earthquake. So if the earthquake emerges out of volcanoes, it is called as volcanic earthquake. The next type of earthquake is collapse earthquake. So this you will see in the mining region. If there is too much mining that is taking place, because of the vibrations of the mining, there will be collapse earthquake, right? Then you have explosion earthquake. Where does explosion earthquake take place? It takes place in the region where there you see because of mining or something, gelatin are used and bombs are exploded. There you have the explosion earthquake where bombs are exploded, right? That may be for various causes, right? Then you have reservoir induced earthquake. So you have big reservoirs, KRS dam, right? Hirakud dam, Bakranangal dam, Narmada dam, all these dams are there. These dams will have reservoirs. Because of those reservoirs also, there will be earthquakes. Those earthquakes are called as reservoir induced earthquakes, right? So how do we measure the earthquakes? There are many ways of measuring the earthquake. The first way is the magnitude. If we measure the magnitude of the earthquake, it is measured on the Richter scale. Magnitude of the earthquake is measured on the Richter scale. This scale ranges from 0 to 10. So if the earthquake magnitude, so whatever you see in the newspaper, it is the Richter scale. So they will measure the magnitude of the earthquake. So if the magnitude is 10, it means the highest possible earthquake. So any magnitude above 5 will lead to lot of destruction, right? So the more the magnitude, more is the destruction. Next you have one more scale of measuring the earthquake. This is intensity scale. So it is also called as Mercalli scale. So Mercalli scale is the it has the value from 1 to 12. So what is Mercalli scale? How is it different from Richter scale? Means Richter scale just gives the number magnitude 5.5, 6 magnitude earthquake, whereas Mercalli scale says that what is the visible damage? How has there any buildings been fallen? Has there been any breach of floods? All these things will be given in the Mercalli scale. That is the difference between magnitude scale and intensity scale. Next you have structure of the earth. So structure of the earth, I will show you the diagram first. So this is the structure of the earth. You have solid, inner core is solid, outer core is liquid, right? And you have the mantle. This is the inner mantle, and this portion forms the outer mantle. Here you have the asthenosphere, right? So above this you have crust. The topmost layer is called as crust. It is up to 100 kilometer thickness from the surface of the ground. And lithosphere means it is approximately 200 kilometers. It is crust plus uppermost mantle. Uppermost part of the mantle is called as the plus crust is called the lithosphere, right? In the mantle portion you have the asthenosphere. In the asthenosphere itself you will have this magma flow, that is flowing in the flow of magma, molten rock, right? So this is the structure of the earth. Inner core, inner mantle, outer mantle, and lithosphere, crust, right? So the crust what we see, it is brittle. What do you mean by brittle? Brittle means it is neither, it is kind of sand or crystal like, right? The crust is having the type of a crystal, right? So it is a brittle body. So you have oceanic and continental crust. The crust on the land is called continental crust. Crust on the ocean is called oceanic crust. So the thickness of continental crust is higher. The thickness of oceanic crust is thinner. This is very, very important because on the land you have mountains, everything. So the thickness is higher, right? And about the density, if you talk about the density also, it is the oceanic crust. It is approximately 2.7 in density. You have continental crust. It is approximately 3 in density. So continental crust also forms the denser body. It is denser also. It is thicker also. Please remember that. Then you have mantle. It starts from Moho's discontinuity up to 1,900 kilometer. Moho discontinuity, it distinguishes between crust and mantle. So from there up to the length of 2,900 kilometer, whatever the part is there inside the earth, that is called as mantle, not mental, right? Mantle. So the upper portion, in the upper mantle you have asthenosphere. Asthenosphere, this upper mantle, this asthenosphere goes up to 400 kilometers below the surface of the earth. In this asthenosphere, it is a weak body. Why it is a weak body? Because there will be rocks in the form of liquid. You have this magma, molten rocks, right? Rocks in the form of fire, right? So that is why it is a weak body. Next you have lithosphere. I already told you, lithosphere is a upper crust plus the upper mantle. So the lower mantle is a solid body. Upper mantle, especially in the asthenosphere, it is liquid. Whereas lower mantle, it is a solid body. Even your core, when it comes to the core, upper core is a liquid body, right? Lower core or inner core is a solid body. So please remember what is solid, what is liquid, right? There is a core mantle boundary. This boundary is at 2,900 kilometer. From the surface, 2,900 kilometer till here you have the mantle. After this, you will see the outer core and inner core, right? So this starts from 1200 kilometers, sorry, how much? 2900 kilometers, right? Outer core is liquid form, inner core is solid form, right? So inner core is made up of what? It is made up of nickel and iron. So it is called as knife, N-I-F-E. Nickel, formula is Ni, iron is Fe. So knife layer is the inner core, right? Next you have volcanoes. Let us discuss about volcanoes. Volcanoes and volcanic landforms. So right, you have active volcanoes. What are active volcanoes? Volcanoes which have erupted in the recent times are called as active volcanoes. Does India have any active volcano? You have in the Barren Island. Barren Island, it has erupted in another in the last century, right? Barren Island is the only active volcano in India, right? So these volcanoes, the magma, it comes from where? It comes from the asthenosphere, right? Magnetic, from the magma chamber. You have magma chamber in the asthenosphere. From that, I showed you asthenosphere, there will be magma chamber. From that magma chamber, volcano will come out, right? Volcanic mantle, right? Volcanic magma will come out, right? So, so what is the difference between magma and lava? If the magma is if the molten rock, see what is molten rock? Rock in the form of liquid is called as magma. It will be very hot, right? If it is within the surface of earth, it is called as magma. If it comes out of the surface of earth, it is called as lava. That is the difference. Inside the earth, magma; outside the earth, it is called as lava, right? So you have lava flows. Lava flows are there. Lava flows means once what are the components of magma, the volcano is, you have lava flows which flows out of the volcano, that is there. Then you have pyroclastic debris. Pyro means fire. So from the fire, heated material, whatever the rocks which are heated, right, within the earth, they come out in the form of debris. So that is pyroclastic debris, right? So you can take it as a heated up rocks, right? Those will come. Then there will be volcanic bombs. Well, when the volcano explodes, there will be a lot of volcanic bombs that will also come out of the volcano. Apart from that, you have ash. Volcanic ash is there, and also you have volcanic dust. Volcanic dust is there. Not only that, you have volcanic gases also, right? These are the components with respect to the volcano, right? So classification. So we classify the volcanoes based on the nature of eruption and the form developed. So what is the nature of the volcano while erupting? What form does it develop into, right? We have, based on the nature of eruption and form developed, we have shield volcanoes. See, shield volcanoes, it will be in this form. It will be actually very big volcanoes. It will be in this form, right? These are shield volcanoes. This will be the shape of shield volcano. So these are the largest of the all volcanoes, shield volcanoes. So you can find these shield volcanoes in the Hawaii region. Where is Hawaii? Hawaii in the Pacific Ocean. Which country does Hawaii belong to? Hawaii belong to USA, right? So there you have Mount Etna. Sorry, not Mount Etna is in Indonesia. There is one volcano in the Hawaii, famous volcano. I forgot the name, right? So whatever the volcanoes you find in the Hawaiian region, that is actually shield volcanoes, right? Not only that, you have basalt flows. Basalt flow means, see, whatever the lava that comes out of it, right? In the shield volcano, it will be actually very fluid. The lava which comes out of the volcano, it is very fluid. So because it is very fluid, it travels the longest possible distance. See, there is this concept of viscosity. What is viscosity? So if the material that comes out of the volcano, if it is in the very fluid form, it is called viscous lava. If it is solid, if it is thick, it is called as high viscosity. So you have this castor oil. Castor oil is highly viscous because it does not flow easily, whereas water is low viscosity. Sorry, water is low viscosity because it will flow easily, right? So this basalt flow, whatever the lava that comes out of the volcano, it is called as basalt. It includes the material called basalt. It will be very fluid, that is low viscosity, so it flows for the highest possible distance, right? So in these shield volcanoes, it will be low explosivity. It does not explode, right? There is no concept of explosion in the shield volcanoes. So in this, sometimes these shield volcanoes explode also. When do they explode? When water gets into it. Somehow the water gets into shield volcano, it will explode, or else it is considered as low explosivity, low explosive volcanoes, right? You have at the end you have the cinder cone. Cinder cone is a concept of shield volcano itself. What is cinder cone? Sometimes what happens, there will be a cone emerging because of explosion. There will be some explosion will happen, and generally though that doesn't happen. If an explosion happens, there will be a cone coming out of it. That cone coming out of the shield volcano is called as cinder cone. Very, very important, right? So then you have the concept of composite volcano. How will be the composite volcano? See, actually shield volcano will be bigger, whereas composite volcano will be like this, narrower, right? There will be many shields, or lava flows like this. Lava would have flown high viscous liquid, because of which they will stop here itself. They won't flow, whereas in the shield volcano, the lava will flow for the largest possible distance, right? So this will be the shields of lava, right? So in this composite volcano, here there will be cooler lava. The lava in the shield volcano, it won't get cooled immediately, whereas in the composite volcano, the lava will be cooler as soon as it emerges outside. And also it is a viscous lava, means highly thick lava will come out of it, right? Thick lava. So there will be a concept of viscous lava. These are very explosive volcanoes. So the volcanoes, composite volcanoes are the explosive volcanoes. Shield volcanoes are not explosive, right? They will have pyroclastic material. Pyroclastic means similar to pyroclastic debris, that is the molten rock type. They will come out of the volcano. Pyroclastic material will be there, and also the accumulation. See, lava getting accumulated here leads to what? It leads to layers. Many layers will be there. Those layers will lead to composition, that is multiple layers will be there. Composite volcano, right? Clear? This is the concept. Next you have some other classifications. You have calderas. Calderas. What is caldera? It is a form of volcano. It is the most explosive among all. Low explosivity shield, composite medium explosivity, highly explosive is the calderas. So what happens? Caldera, actually they don't build any structure. See, there will be structure like this. Here explosion will happen. This will collapse. The volcano will collapse within itself. Because of huge explosion, it will collapse within itself. That is the collapse on themselves. These are called calderas. So there will be caldera lakes. So once they collapse, this region will get, there will be plain region. Here water will get accumulated. There will be caldera lakes, right? So close, and why there are huge explosion in the caldera volcanoes? Because the magma chamber supplying the magma, as the asthenosphere will be closer, the magma chamber will be closer to the surface. That is why huge explosion, whereas in other volcanoes the magma chamber will be below, much below, and also the magma chamber will be very huge. Very huge, that is why there will be high explosivity, right? Next you have flood basalt province. What is flood basalt province? So you have in this flood basalt province, this is highly fluid lava. So if you want to understand flood basalt province, you take the example of Deccan Plateau. Deccan Plateau, where it is? From the southern peninsula, Indian peninsula. You see the Indian map, right? Whatever is there here is the Deccan Plateau. So it includes Andhra Pradesh, some part of Karnataka, Maharashtra Plateau, and also Gujarat. It goes up to Aravali Hills in Rajasthan, and it comes here in the east. It goes up to Rajmahal Hills, right? That is the Deccan Plateau. So the Deccan Plateau, it is a flood basalt province. Means what? From an volcano, basalt will come. Basalt lava will come. It will spread over a long distance. That is the flood basalt province, right? Flows for a long distance. Highly fluid lava. There will be very high fluid lava which flows for a very long distance. So you have Deccan traps. That is, Deccan Plateau is the example of the flood basalt province, right? So it will be for hundreds of kilometers. It will be spread for hundreds of kilometers, right? So very big ones. Then you have mid-oceanic ridge volcanoes. So you know where is this mid-oceanic ridge? It is in the Atlantic Ocean. So where is Atlantic Ocean? Between, so here is Europe, here is Africa, here is North America, here is South America. Whatever is in between is the Atlantic Ocean. On the left of America, you have Pacific Ocean. So please know the oceans. Where are the oceans, right? So on the right of this Africa, you have Indian Ocean, right? So in the Atlantic Ocean, this there is a chain of mountain. There is a big chain of mountain. Actually, the largest mountains on earth are found in the Atlantic Ocean, in the mid-ocean Atlantic ridge. So it composes both the northern hemisphere and southern hemisphere. The longest chain of mountains on the earth are in the Atlantic Ocean, right? It is mid-ocean. This is called as mid-oceanic ridge. So in these mountains, at the top, at the crest level, there will be volcanoes. Those volcanoes are called as mid-oceanic ridge volcanoes. So it is actually how much? 70,000 kilometers long. The length of it is actually bigger than the Himalayas, right? So it is 70,000 kilometers long, or I think it is 7,000 kilometers, not 70,000. So it is 7,000 kilometers long mountain chain, right? Their volcanoes are called mid-oceanic ridge volcanoes. Then what are the landforms that is born out of the volcanoes? So you have intrusive forms. Intrusive forms means what? See, intrusive means within the earth. Within the earth, whatever the whatever the landform that forms is called an intrusive landform. So lava, cooling lava within the earth. If the lava cools off, that is the magma cools off within the earth, there will be intrusive landform within the earth. So these rocks which are formed out of the lava are called as igneous rocks. From the magma, whatever rocks form, they are called igneous rocks. So these lava can be cooled within the earth or outside the earth. So within the earth or outside, both sides it can cool, right? If it is cooling outside, if the lava comes outside the earth, on the surface of the earth, it cools down. It is called as volcanic rocks. If it cools within the earth, if the magma cools within the earth, whatever the rocks that are formed as plutonic rocks. Within the earth, plutonic rocks. Outside the earth, it is volcanic rocks. So you have in the crust. In the crust, there will be cooling. Cooling happens in the crust. That is intrusive landforms. Intrusive landforms will be found in the crust, right, within the earth. So when the cooling happens in the part of the crust. So first landform you find is the batholith. So batholith, I will show you in the diagram. So This is your batholith, whatever you see here. The biggest one is the batholith. This is the volcanic landforms, right? So batholith, it is the large magma material cooling at deeper depth. If the biggest magma, the largest material of magma cools within the earth, it is called as batholith, right? So it cools at a deeper depth, very deep within the earth, it gets cooled, right? So it forms large domes. There will be very large domes forming within the earth because of batholith. It will be in the form of a dome. Large dome will be formed. All this will be it will be rock, right? So this will form in the deeper depth, very deep depth it will form, right? So large domes will be there. So what will be the material of the batholith? It is granite. Batholith is formed out of granite. Next you have, so I'll explain the diagram. You have dikes. What do you mean by dike? If the lava cools in the vertical position like this, it is called as dike within the earth or outside the earth. If it cools in the horizontal position, it is called as what? Sills, right? You have sills here if it cools in the horizontal position. Also you have laccolith and lopolith. I'll explain what it is. Outside earth, what will be the landform? You have lava plateau. Just like Deccan Plateau, if there is a table land in the form of table, it is lava plateau. Then you have cinder cone. Okay. Then you have cinder cone. Cinder cone is a small type of cone. It is a smaller version of volcano that is there. Then lava mesa. It is a smaller form of lava plateau, is called as lava mesa, right? Then a composite volcano is there. Then dikes. See, dike can be within the earth also, outside the earth also. A vertical landform, right? Then you have, I told you, calderas. Caldera lakes. Caldera landform is also there, right? Here. So this is then you have laccolith. See, above the batholith, if there is horizontal landform within the earth, above the batholith, it is called laccolith. So it will be there are two bodies, one is laccolith and lapolith. So laccolith means what? If the lava cools in this position horizontally, right? This is smaller than batholith, above the batholith, right? In this position, if the lava cools horizontally, it is laccolith. What is lapolith? Lapolith means if it cools in saucer shape. If the lava cools in the saucer shape, it is called lapolith, right? All this, it is based on how the landform is there, or how the magma will cool within the earth. Based on that, we have lapolith, laccolith, batholith, all these landforms, right? So you have laccolith. I told you laccolith is large dome shaped intrusive bodies. So it is like this. Laccolith, I told you no, laccolith. It is a large dome shaped intrusive body connected by a pipe like conduit. So there will be a pipe like conduit from the magma chamber. Here it is there. See, here it is laccolith is there. Above this laccolith, you have below this laccolith, you have a pipe of conduit, right? This is the laccolith. Pipe-like structure. So it is a localized source of lava. Below it, below the laccolith, there will be a localized source of lava which will come up, right? So Karnataka plateau is the example of laccolith. So laccolith will also have granite. Karnataka plateau is the best example for laccolith, right? Then you have lapolith. So laccolith is in this form. If it is in the saucer shape, it is called lapolith, right? So horizontal direction along weak plane. So laccolith, phacolith, sills, what are they? They are horizontal bodies. Horizontally, if the lava goes in the horizontal position, not vertical position, if it cools in the horizontal position, you have these bodies, lapolith, phacolith and sills, right? So saucer shape is there. Saucer shape is laccolith. Laccolith is in saucer shape. Please remember. Then if there is wavy mass of synclines and anticlines, it is phacolith. That is, if it is like this, if the lava cools in this position or in this position in the form of wave, so it is called as what? In a phacolith. Wavy landform is called phacolith. Then you have sill or sheet. Sheet means if there is just one, see, if there is volcano chamber is coming, is like this, magma is coming like this. So if the magma goes like this in the form of a horizontal plane, it is called as sheet. In the form of sheet, if the volcano magma cools, it is called sheet, right? If it cools, if the sheet thickness is more, it is called as sill. If the thickness of the magma is more, it is called as sill. A smaller thickness, it is called as sheet. Bigger thickness, it is called as sill. Right? This is the difference. Then you have dikes. Dikes means, so via the cracks, if suppose this is earth, there will be lot of cracks. Within these cracks, the magma will come out and there will be dikes forming like this. Right? Our vertical bodies will be projected outside the earth or called as dikes. They come via cracks and fissures. Right? So they get solidified perpendicularly. They will be solidified in the perpendicular direction. So, and they get cooled in the same direction. It comes in the vertical direction and also cools in the same direction. You find these dikes in the western Maharashtra region. Right? So this is about the volcanic landforms. Next, we will move towards the distribution of oceans and continents on the earth. How is the ocean and continent distributed on the earth? So you have 29% of the earth is land, rest 71% is water, right? This land from the ancient time, it has been changing its position. So what you see as India, it is not in the same position millions of years ago. It was there somewhere else, right? So this landform is changing its position. First we have with respect to changing landforms, the first theory given by Wegener, Alfred Wegener, is continental drift theory. So today we have 7 continents. He says these continents were not in the same position. They were drifting along across the earth throughout the history, right? That is what the continental drift theory says. So what is the, he says the entire continent, all the continents together formed one single body earlier. So that single body is called as Pangea. P-A-N-G-E-A, Pangea. Right? And that is single continent. All the 7 continents formed one single continent called as Pangea, and there was one all water body. So around this single continent, whatever the water body was there, it was called as Panthalissa. Panthalissa, right? So he says what is the proof that Alfred Wegener gives to prove his point that all the continents were together? You should take the example of the African coast and South American coast. If you look at the map of the Africa and America, right? So where do I write it? Okay. So you take the example of Africa. So this is South America, and you have Africa something like here. In the middle, you have Atlantic Ocean. So he says these two bodies can be, if you fix it, if you bring together and fix it, they have they fit perfectly, right? So whatever the difference, so this is like this, and Africa is actually, I'll draw a neater diagram. So you have, this is South America and this is somewhat Africa. So if you fit these two bodies, this will fit perfectly. That is the proof given by Alfred Wegener, saying that both the bodies were together in the earlier times. Both South America and as well as Africa were together, as said by the Alfred Wegener, right? Coastline of Atlantic, on the both sides of Atlantic, whatever the coastline is there, if you fit them perfectly, they fit perfectly, right? So that is the proof given by Alfred Wegener. He is a German meteorologist. He gives the continental drift theory in the 1912. This continental drift theory is given in 1912. So he says that there was a single continental mass and a mega ocean. Single continental mass is called Pangaea. Mega ocean is called as Panthalassa, right? This was there 200 million years ago. After 200 million years ago, this single continent got separated. It broke into multiple pieces. So it broke into Laurasia and Gondwana land. So the northern part broke into Laurasia and the southern part broke into Gondwana land, as per the Alfred Wegener theory, right? So what is the evidence to support of the continental drift? See, continental drift means the continents are drifting. They are moving around the oceans, right? So what is the evidence to support the continental drift? One is the jigsaw fit. Jigsaw fit means what? If you fit the South America and Africa, they will fit perfectly along the coastline. So that is the jigsaw fit concept. So that according to that, there is a evidence for continental drift. Then you have, if you find the rocks on both the sides, if you find the rock on the South American side and also if you find the rocks on the African side, both the rocks are of same age. Both of them have the same age. So this same age, how it is found out? By radiometric dating. By radiometric or carbon dating, they find out the age of the rocks. So both of them are of same age. Also the marine deposits on the both the sides, they belong to Jurassic age. On the side of Africa as well as the South America, whatever the marine deposits are there, both of them belong to the Jurassic age, right? So that is one evidence. The second evidence. Then you have tillite, right? What is tillite? See, you have glaciers, right? What is glacier? Ice mass of ice from where all the rivers originate. So when the glaciers move, below that there will be lot of soil, right? Soil, rocks, debris, all these things. That is called as tillite. So tillite means it is sedimentary rock formed out of glacier deposits. So what is sedimentary rock? We will discuss, right? Sedimentary rock formed out of glacier deposits is called as tillite. So this tillite, actually if you see Gondwana sediments from India. So I told you the Pangaea broke into what? It broke into Laurasia and Gondwana land. So in the Gondwana land, whatever the sediments are there, tillite, it is actually found in Madagascar. The same tillite is found in Madagascar. Where is Madagascar? In the Indian Ocean. And it is also found in the African region. It is also found in Australian region. Based on this, we can conclude that tillite evidence, all these places were one earlier, right? Were together earlier, right? Not only this, if you find the classic example of the Africa and South America, the tillite on both the sides actually are same, right? That is one more example. Then placer deposits. Placer deposit means, see, gold. So gold deposits, gold in the smaller chunks, in the form of small rocks, golds are there, gold or silver, those are called placer deposits. See, these placer deposits, gold is found in Ghana in Africa, whereas the gold bearing veins, for the where the gold come from, the veins, they are in Brazil in South America, right? That is why it says that these two continents were earlier together, later separated by the Atlantic Ocean. So the gold veins, placer deposits is one more evidence. Then you have distribution of fossils. Fossils means what? So the dead organisms of plants and animals is called as fossils, which are stored within the earth in the same shape, in the form of rock or something, right? If you see Lemuria, so lemurs, there was one organism called lemurs. These lemurs were actually found in India, Africa and Madagascar. So this land together, India, Africa, Madagascar and Australia was together known as Lemuria, right? Lemurian land, right? Later on, this got separated. That is one theory as per the continental drift theory. Then you have the example of Mesosaurus. So Mesosaurus was a type of dinosaurs found both in Africa and South America, right? That is one example. So the fossils are found on both the sides. Then you have force of drifting. So Alfred Wegener says these continents are drifting. They are drifting around. They are moving around. What is the force for the? Because of what force are they drifting? So he says there is a pole fleeing force. What is pole fleeing force? See, the earth is rotating, right? So because of earth, rotation of the earth, there will be some force. So you can take this force as centrifugal force, right? Whenever you rotate a body on the outskirts, whatever the particles are there, they will be moving away, just like centrifugal force, right? If you rotate something, if you tie some rock, some 5-6 rocks to a pole and rotate it, all the rocks will be moving away, right? That centrifugal force is one force. That is because of the rotation of earth, there is pole fleeing force. That is the first force as per the Wegener. Also tidal force. Tidal force means the force of sun and moon. Force because of sun and moon's gravitational attraction, you have tidal force, because of which the continents are moving. These are the two forces given by the Wegener. But later on, Wegener's concept, Alfred Wegener's concept was opposed. Many scientists opposed them and they gave post-drift studies. What is post-drift studies? Evidence. They say till now we are looking for evidence only on the continents. But what about the evidence in the oceans? See, if there are two continents, between the two continents, whatever the space is there, that is not empty space, right? So that two continents can come and merge. Below that also there is land. Over that land, water is there, right? So he says, post-drift studies say there is evidence apart from the continents in the oceans. After World War II, they find out other information about the oceans. In the ocean floor, there will be lot of relief in the form of mountains. There will be lot of mountains, trenches, everything. So there is a world within the oceans. So you should check the evidence for continental drift from within the oceans also. That is what is said by the post-drift studies. So then you have convectional current theory. What is convectional current theory? So you have this asthenosphere. In the asthenosphere, there is magma flowing. Because of the flow of magma, there is a current moving, right? When the magma flows in the asthenosphere, because of which there is a convectional current. Because of the heat, there is some convectional current, because of which the continents are moving around. This theory, convectional current theory, was given by Arthur Holmes in 1930. He gives this theory in 1930. So convectional current will be flowing in the mantle portion, right? Next you have mapping of the ocean floor. So mapping of the ocean floor is called bathymetric studies. So in the bathymetric studies, when they study the ocean floor, what happens? It is full of relief, full of mountains, full of various landforms within the oceans. So they say only you cannot say that the ocean floor is empty, right? That is the concept. So also the rocks, if you look at the rocks on the continent, if you look at the rocks on the oceans, the oceanic rocks are younger, right? They are formed very recently compared to the continent rocks. That shows that ocean landform is a lively landform. It is not a continent is not the sole landform, right? So it is full of relief. Younger rocks are there, and also you see either side of the crest of the ridges. So you have this mid-oceanic ridge, right? Mid-oceanic ridge in the Atlantic Ocean. So in the mid-oceanic ridge, see here you have South America, here you have Africa. So here you have the Atlantic Ocean. In the middle there is mid-oceanic ridge. In the mid-oceanic ridge, whatever the volcanoes are there, so the volcanoes emerge out of the crest. Crest means what? The topmost part of the mountain. From that, lot of volcanoes emerge. If you look at the crest of the ridges and also equidistant rocks, see when the volcano flows, the volcano lava will flow like this on either side. So if you look at the rock from here, which are equidistant from the crest, if this is the crest, if you look at the rocks which are equidistant from the crest, both are belonging to the same age, right? Both are of same age, which gives evidence that both the rocks were formed out of the same volcanic eruption, right? All this gives that all this information shows that there is a earth, the landform within the ocean is a very lively environment. It is not a still environment, right? Either side of the crest of the ridges and equidistant rocks, there are similarities. So they are similar in structure, they are similar in age, and they are similar in composition. Both the rocks on the either side of the crest of the mid-oceanic ridges. Then you have ocean floor configuration. What is the configuration of the ocean floor? We have three major divisions with respect to ocean floor. So what are the three major divisions? So it is actually the first is continental margin. What is continental margin? You look at the seashore, or if you look at the beaches, right? That forms the continental margin. That means the margin of the continent and ocean. The boundary between the continent and ocean is called as continental margin. There are three major divisions. First is the continental margin. The second is the abyssal plains, and third is the mid-oceanic ridges. So the boundary between the continent, see for example, the boundary, you take the example of Chennai. Chennai forms the boundary between land and ocean, right? That the beach side of Chennai can be called as continental margin, right? So it is a transition between shores and deep sea basins, transition between the seashore and deep sea basin. What is deep sea basin? Within the ocean there is a big basin. So the transition zone between the continent and the basin in the ocean floor is called as what? It is called as the continental margin, right? So with this continental margin, it can be divided into multiple sections. One is the continental shelf. Continental shelf. So what is continental shelf? This forms the first part. See, if there is, one second. This is the oceanic plain. That is bottom of the ocean there is plain. This is the continent. This part is the continent, right? So this is the continental slope. That is, continent is sloping into ocean. This part is called continental slope. This part, the boundary between continent and the ocean is called as continental shelf. Then you have continental rise. This part is called as continental rise. See here, continent is rising from the deep sea plain, right? That is there. Then you have deep oceanic trenches. Trenches means within the oceanic plain there will be deep, very deep places in the ocean. Those are called trenches. Which is the deepest trench in the world? It is the Mariana Trench. Trenches means it is just like valleys. So these will be valleys within the ocean, right? So deepest points in the earth. So you have the Mariana Trench. So these are the 4 points in the continental margin. First is continental shelf, second is continental slope, third is continental rise, fourth is the deep oceanic trenches. This is the transition zone between the shore, seashore and the deep sea basin, right? There are 3 major divisions I told you. This is based on the depth and form of relief. At what depth it is there and what is the form of relief, based on that this differentiation is carried out. Next you have abyssal plains. What is abyssal plain? The oceanic plain. The ocean, the plain within the ocean, the land within the ocean is called as abyssal plain. So this is the plain between continental margin and ridge. So here the continent is getting into ocean. This is ocean, and here there is mid-oceanic ridge. I told you in the Atlantic Ocean. So between the margin, continental margin and the ridge, whatever the land is there, that land is called as what? Abyssal plain, right? Abyssal plain. So here what will be there? Sediments. See, from the mid-oceanic ridge also volcano will come and sediments will get deposit, and also from the continents also rivers, everything will come and the sediments will get deposited here. So because of both these things, in the abyssal plain there will be lot of sediments, right? This is a place for sediments, abyssal plains, right? Next you have mid-oceanic ridge. I told you about mid-oceanic ridge. So it is a form of mountain chain within the Atlantic Ocean. It is the longest mountain chain system. Mid-oceanic ridge is the longest mountain system. Here there is a rift at the crest. Rift means a opening. A opening is there at the top of the mountain. In the mountain there will be one opening from which the volcanoes will pour out, right? That is there is a rift at the crest. Next you have distribution of earthquakes and volcanoes on the earth. How earthquakes and volcanoes are distributed, right? So where is the mid-oceanic ridge? See, this is the mid-oceanic ridge. I told you, no? See, this is South America, this is Africa. I told you, no, jigsaw fit. Jigsaw fit means, see, if you take the African continent and take the South American continent, if you fit it together, they will fit properly. This is the jigsaw fit given by Alfred Wegener. Then mid-oceanic ridge, this is the longest mountain system in the mid-oceanic ridge. So here this is how the earthquakes are spread across the world. So you have hot spots of earthquakes. See, this is Pacific Ocean. So whatever the big black dots you are seeing, all these are hot spots. Hot spots means there will be lot of earthquakes, deep hot spots of volcanoes. Then you have volcanic eruptions. So whatever the black small dots you are seeing, see, this is called Pacific Ring of Fire. Means, see, this forms like a ring, right? This entire thing, black dot. So this ring is called as Pacific Ring of Fire. There will be fire, means volcanic fire will be there. This is the diagram, right? So whatever the black dots you are seeing, they are volcanic eruptions. So you have light small dots are there, right? So these are shallow earthquake centers. The light dots you are seeing, right? Small, in the light color, they are shallow earthquakes. That is not deep earthquakes. Whereas you see the darker ones here. You see the darker region. Here darker region is there, right? This darker region is deep earthquake regions. There will be very deep earthquakes in those regions, right? This is how the earthquakes and volcanoes are distributed across the world. Then you have sea floor spreading. So what is sea floor spreading? So I will show you in this diagram only. So here there is mid-Atlantic ridge. So in this mid-Atlantic ridge, at the crest of the volcano, there will be series of volcano. At the crest of volcanoes, lava will pour out. So from the lava which pours out, what happens? The lava will spread like this, in this direction and also in this direction. So if you take the rock of here and here, it will be of same age. That is what seafloor spread. So seafloor spreading in the mid-oceanic ridge, huge lava will come to surface, right? That is the first point. So equidistant rock on both the sides, they have similarities. Both have similar values, similar composition, similar age. So closer ones, the rocks which are closest to the mid-oceanic ridge, they are youngest. Why youngest? Because see, whatever the recent lava that would have flown, that will be the closest. Whatever the oldest lava that flows will be farthest, right? So youngest will be closer, oldest will be farther, right? So closer ones are the youngest, closest rocks are the youngest. Oceanic crust, see, oceanic crust younger than continental crust. The crust of the ocean is younger, right? Continent is a older landmass. This point you should remember. So there are very thin sediments in the ocean. See, in the continent there will be very high sediments. Thickness is high, whereas continent oceanic basement is very thin. Continental basement is very thick, right? This difference you should know, right? There are very thin sediments in the ocean, and also there are deep trenches. Deep trenches in the ocean. Trenches means, I have told you, they are valleys within the oceans. So there are very deep trenches. In these trenches, there will be deep-seated earthquakes. Deep-seated earthquakes. So this is the basic information about the topography of the ocean. But this is required for you to understand seafloor spreading. What is seafloor spreading? So this process, this concept was proposed by Hess. Hess says that there is a concept of seafloor spreading. He gives this concept in 1961. What is the seafloor spreading? There is constant eruption from the volcano. Because of this constant eruption, see, here there is constant eruption coming out of the volcano, right? So there is constant eruption, because of which what happens? This crust will be there, right? The crust, upper portion of the lithosphere, right? That crust will rupture, that will break away because of constant volcano coming out, right? When the crust will rupture, what happens? When the crust will break away, it will push the land on either side. So when the land is pushed, when volcano comes out, the crust will break away and both the crusts will be pushed aside. When it is pushed aside, what happens? Consumption of oceanic crust will take place. Means what? See, when the crust moves away, there will be new magma which will come and takes its position. I will show you it in the diagram. See, here there is volcano coming up, right? And lithosphere, crust is moving on both the directions. It is moving away. When it is moving away, the volcano is coming up. When it comes up, what happens? The crust will rupture and it will move away, and this volcanic magma will get solidified and new crust is formed. Or on the other hand, here there is continental margin. Here this is ocean, this is continental boundary. So here what happens? The crust will be pushed to this side and this side because of volcano. This crust, here there is continental margin, continental boundary is there. What will happen? This crust will sink within, because it cannot push the continent, right? So what happens? It will sink within the or downside the continental crust. Oceanic crust will go below the continental crust at the continent boundary. In the mid-oceanic boundary, it will spread, right? This is the concept of sea-floor spreading. Sea-floor is spreading. Clear? Right? Hess proposed this. Consumption of the oceanic crust. See, at the continental margin, the crust is getting inside. Crust is getting consumed. That is the consumption of oceanic crust. This sinks, also this crust sinks at the trenches. Trenches means, so you have, trenches means deep valleys. Here there is no trenches. So trenches means deep valleys. So what happens when the crust is moving? What happens? It will sink within the trenches also. Not only below the continents, but also in the trenches also the crust will sink. Right? This is the concept of sea floor spreading. Okay, if there is anything I should explain here. See, this is continental crust, oceanic crust. It is subducting. Subducting means going within. Right? Here is you have asthenosphere, lithosphere is moving either side. Here you have oceanic spreading, ridge is there. There is shield volcano, transform plate boundary. I'll discuss what is convergent, what is. So here you have a stratovolcano. Okay. Next you have plate tectonics. What is plate tectonics? This concept is given by Mackenzie, Parker and Morgan in 1967. MPM or PMM. Mackenzie, Parker and Morgan gave this concept of plate tectonics in 1967. They say they gave this concept of lithospheric plate. Lithospheric plate means crust and what? Crust and upper mantle. This will move over the asthenosphere. That is the concept. There is this lithospheric plate is a massive slab. It is a massive slab is there. Right? Massive slab of rock. So this continental, this lithosphere in the continental margin, it goes up to the depth of 200 kilometers. Whereas in the oceanic region, it goes up to 100 kilometers. Right? 200 kilometers in the continental space, lithosphere. Lithosphere is not constant. It is not constantly 200 kilometers. In the continental region, it is 200 kilometers. Oceanic region, it is 100 kilometers. This entire lithosphere will form a plate. Right? This plate will move across the world. Right? I'll show you the plates. Continental, there is continental plate and oceanic plate. And also, there are major plates and minor plates. So, what is continental plate? What is oceanic plate? What is major plate? See, this is the entire earth. So, North American plate. See, this entire North America, it is one plate. It is sitting on one lithospheric plate. So, this is a major plate. Even you have, see, Europe and Asia is one plate. It is sitting on one plate, right? Eurasian plate is there. Then you have, these are major plates or continental plates. You see here, Pacific plate is there. This is a oceanic plate. It is in the ocean, right? So, these are the major plates. Not only major plates, there are minor plates. Cocos plate is there. Nazca plate is there. Caribbean plate is there. East Pacific rises. Philippines plate is there. Caroline plate is there. These are, and also you have Arabian plate is there. All these are small plates. These are bigger plates. North American plate, South American, African, Eurasian. All these are Indo-Australian plate. All these are bigger plates. Pacific plate also bigger plate. All other things are smaller plates. See, here you have Antarctic plate. That is also a bigger plate. Right? Okay. So, these plates, they move horizontally over asthenosphere. Right? Asthenosphere is there. Over that, it is going to flow around these lithospheric plates. So, you have Antarctic plate, North and South American plate, Pacific plate, Indo-Australia, New Zealand plate, African plate, Eurasian plate. I showed you all of these. So, this is major plates. Minor plates you have Cocos plate, Nazca plate, Arabian plate and Philippine plates. All these are minor plates. Next you have continental mass resting over plates have been wandering. See, these continents which are over the, which are over what? Which are over the plates. They are, it is not the continents which are moving around. Rather, the continents which are resting over the plates. Right? These plates are moving around over the asthenosphere. That is what is said by these people. Right?
there are three types of plate boundaries, right? What are the three types? You have divergent boundary. What is divergent boundary? See, here, because there is volcano coming up, the crust is moving away. It is diverging. So this is diverging plate boundary. Then you have convergence plate boundary. See, here continental plate boundary is there. Here oceanic plate boundary. Both are coming together. Right? So this is convergent plate boundary. One plate is going down, one plate is moving up. So this is convergent plate boundary. Then you have transform plate boundary. Here you have transform plate boundary. What is transform plate boundary? See, it is, see, divergent means going like this. Convergent means coming like this. Transform means it is going like this, side by side. So transform plate boundary. See, one plate is going like this, another plate is going like this. That is transform plate boundary, right? So divergent plate boundary, what happens here? New crust is generated. See, here since it is moving away, new crust will form because of the volcano and lava, right? New crust will get generated in the divergent plate boundary. So these divergent plate boundaries, these are spreading sides. Right, I told you sea floor spreading, because there will be divergence. What happens? Sea floor will be spreading. So these are spreading sides. The best example is mid-Atlantic ridge. The next is convergent plate boundary. See here, crust is destroyed. Destroyed means, see, crust is going down, right? So it is getting destroyed. So convergent plate boundary, crust is here also, it is getting destroyed. Crust will get destroyed in the convergent plate boundary. Then you have, these are subduction zones. Subduction zone means one will go below the other. Subduction zone, right? So there are three ways of convergence. Three ways of convergence. What are the three ways? One, it is either ocean continent convergence. Oceanic plate and continent plate might converge. Or there might be oceanic plate and oceanic plate might converge. Or that might be what? Continent plate can converge. I will show you the example. So see here, this is a oceanic plate, this is a oceanic plate. If they come together, it is oceanic convergence. See here you have, you have Eurasian plate, Indo-Australian plate. See, this is also a continental plate, this is also continental plate. Continent plate is converging, right? Ocean continent converging is, the best example is, you have, take this plate, Pacific plate and Eurasian plate. So both of them are coming together, continent ocean convergence, right? This is the example. Okay, so transform plate boundary means the plates will transform past one another. So slide past one another horizontally. So here what happens? There will be transform faults. Faults means, see, if the plates, if they are like this, if they move like this, if they go together like this, what happens? In between there will be fault. Fault means crack. There will be a crack. There will be transform faults across the transform plate boundary, right? This is the concept. Next you have what? Rates of plate movement. How fast are the plates moving, right? That rate, how fast the plates are moving, it is determined by the magnetic field. How strong the magnetic field is, based on that the rate of the movement of the plates is determined. Clear? So Arctic ridge, in the Arctic region the plate is moving slowly, whereas in the East Pacific rise region the plate is moving very fast. So this is the difference, right? Then you have force for the plate movement. What is the force based on which the plate moves, right? There is a dynamic interior within the earth. Whatever is there, it is dynamic, right? Dynamic means very fast movement. So earlier it was believed within the earth everything was static. There was no movement. Earth, with the interior of the earth is a static portion, was believed earlier. Whereas after research after 19th-20th century, we found out that interior of the earth is not a static place. It is full of dynamic nature. There is lot of movement, right? So there is a dynamic interior, right? There is a mobile rock moving in a circular manner. Means what? What is mobile rock? It is your magma. Magma is what? Mobile rock. It is moving in a circular manner, right? So there is a mobile rock which is moving in the circular manner, which is that is the force for the movement. Since this magma moves, with the magma, the plate will also move. Because of the movement of the magma, the plate will move. There is a convection cell or flow. Convection cell means what? There is a cell like this. Convection cell. The magma will go, magma will flow, and it will come up in the form of volcano. Wait a second. So here is the asthenosphere. Magma will come, it will flow, it will spread, again it will go within. Right? So there is a cell, right? So here also magma comes, it comes to the surface, it goes in the subduction zone, it gets into the asthenosphere, right? Or in the trenches it gets to the asthenosphere, there is a cell. So this is the convection cell, right? So there is a convection cells or flow. This cycle is repeating, right? Magma coming to the surface, going back, convection cell. That is what is the force for tectonic plates to move, right? So there is a and also apart from this magma, there is lot of heat. So in the magma itself, there is lot of heat. So which is the source for this heat? The source, where does this heat come from? It comes from the origin of earth. I told you in the originate of the earth, there was lot of heat. From there, the heat will come. Also, the heat will be there because of radioactivity, radioactive decay, radioactive materials decay within the earth, because of which also there will be heat, right? Residual heat means heat from the formation of earth and radioactive heat. Because of both these things, we have what? The force for the plate to move, plate boundaries to move. Then who gave this concept of plate, this thing, what? Convection cell. It was given by Arthur Holmes. Arthur Holmes gives this concept of convection cell in 1930, right? So mantle is the driving force. Mantle which is flowing, it is the driving force for the plate boundaries to move, right? Then movement of Indian plate. How did Indian plate move? First I will show you the diagram. So earlier Indian plate, this is equator, it was below equator 71 million years ago. Later, can you see the shape of India here? So Indian plate 55 million years ago, it moved little up. Later 38 million years ago, it moved still further. 10 million years ago, it came to the position which is there now, right? After that, it collided with the Eurasian plate. The Indo-Australian, see, Indian plate is not just India, it is India and Australia combined. India-Australian plate collided with the Eurasian plate, right? So this is the concept, movement of the plate. So earlier peninsula plus Australian. So Indian plate means Indian peninsula plus Australia. Both of these things form one plate, right? So this plate, what happened? Heat started moving towards the north and collided with the Himalayas. When it collided with the Himalayas, what happened? There was a collided with the Eurasian plate. There was no concept of Himalaya. See, Indian plate was coming like this, and there was Eurasian plate. This was Eurasian plate, Indian plate. They come and collide together. When it collided, there was lot of friction, because of which Himalayas come up, right? Himalaya come up because of subduction. Because when two plates collide, what happens? There will be lot of friction. Something should come up. That thing is Himalayas, right? So the northern boundary is the Himalayas. What is the eastern margin? On the eastern margin of the Indo-Australia plate. It is towards the right of Australia. Eastern margin is here. Eastern margin of Indo-Australia plate ends here. Northern margin of Indo-Australia plate ends here. Right? Western margin ends here towards the Africa. Southern margin, it ends here, somewhere here. Right? These are the margin of Indo-Australian plate. Western margin I have told, eastern margin, southern margin is Atlantic. So northern margin we have Indian plate colliding with the Eurasian plate, right? That is convergent plate boundary. On the southern margin, what is there? There is divergence. There is divergence of plate boundary on the southern margin, right? So this earlier, whatever separated, no, this separation. See, here is Eurasian plate. Eurasian plate is there. Here, India was earlier here, right? So in between there was one sea. That sea is called Tethys Sea. T-E-T-H-Y-S. Tethys Sea, right? It was there. 200 million years ago, India started moving towards the north. Below the equator, it started moving towards the north, right? Okay. So this is about the plates, Indian movement. So this completes the chapter on what? Distribution of oceans and continents. Next, we will move towards the minerals and rocks. So what are minerals and rocks? Give me a second. One second. There is some important thing I have to attend. Okay. On this live channel, I would like to announce one good news. I have cleared IAS exam. I've got interview call. The results are out. Thank you. Okay. So next month I'll be going to Delhi for interview. Okay. Let us continue the geography. Okay. So because clearing IAS exam, you know, right, how difficult it is. I've been behind this exam for so long, almost 5 years. So this will be my third interview. I've given 2 interviews. This will be my third interview. Hope this will be my last interview and I get my post. Okay. Okay. Let us continue to the class. Solid and molten form. So what is minerals and rocks? So mineral. What is mineral? You have iron ore. You have so many things, right? So this happens because clearing prelims itself is such a big task in UPSC, and when you clear mains and you have to go to interview, feel so happy. So I wish you also clear your whatever goals you are aspiring for. Okay. Okay. So minerals and rocks. So what are the minerals? What are the rocks? So minerals means you have whatever iron ore, whatever copper, whatever you find within the earth, those are the minerals. Minerals consist of multiple elements. It consists of multiple elements, right? So, you have elements, copper is an element, iron is an element. So, all these things come together as a mineral, right? So, the minerals and rocks will be in the solid form. It will be in two forms. One is either the solid form or it will be in the molten form. There are only two forms. One is solid form, other is molten form, right? So, 98% of the crust, 98% of the Earth's crust, it is consisting of 8 elements. 98% is just of 8 elements. So, these 8 elements, they will ask you which is the highest number of elements. You should know these elements. So, the topmost element is oxygen. Oxygen consists of 46.60%. Right? Silicon consists of 27.72%. Right? Aluminium, oxygen is the highest number, first. So, which is the topmost element on earth? It is the oxygen. Next is silicon, 27.72%. Third one is aluminium. Third is aluminium. Fourth is iron. So, the composition of aluminium is 8%. Iron composition is 5%. So, if you know the percentage of first 4 elements, it's enough. But there are 98% of the crust is of 8 elements. The oxygen, silicon, aluminium, iron, calcium is there, sodium is there, potassium is there, magnesium is there. These are the 4 other elements. So, 8 elements you should know, especially the top 4 elements. So, these elements combined with other substances, when the elements come together among themselves, or if the elements are combined with other substances, so those are called as what? Minerals. The elements coming together with other elements or with other substances, it is called as minerals, right? So, you have 2 types of minerals. One is organic mineral, other is inorganic mineral, right? So, there are 2000 type of minerals on earth. Totally 2000 type of minerals are there on earth, right? So, 6 major rock forming minerals are there, out of which 6 are the major rock forming minerals on earth, right? So, what is the source for these minerals? The minerals come from the source magma. Magma, you know what is magma. From the magma, the minerals will come up, right? So, this magma, when it cools, it will become the rock or a mineral, right? So, the minerals are formed out of magma. When this magma cools, it becomes a rock or a mineral, right? So, there are what types of minerals? There is solid minerals, liquid minerals, as well as gaseous form of minerals, various type of minerals. So, what are the physical characteristics of the minerals? See, the first physical characteristic is external crystal form. Crystal form is whether the crystal means how the mineral, if you look at the mineral, how it is, whether it is brittle. Brittle means whether it is in the form of sand or whether it is in the form of a solid crystal. That is the external crystal form, right? Crystal form of the mineral. Then you have cleavage. So, cleave means if you break a mineral, according to what plane? See, if there is a mineral like this, if you break the mineral, according to what plane? This plane it will break. So, if you break it, only according to this plane it will break. This plane is called the cleave. If you break it by hand or by anything, the mineral will break in that direction only. That is the cleave. Then fracture. What is fracture? It means if the mineral doesn't break according to the cleave plane of cleavage. This is called plane of cleavage. If it doesn't break according to the plane of cleavage, it is called as fracture, right? Then you have luster. Luster means appearance, shining. If the mineral is shining, if it is not shining, right? That shining is called as luster, right? Appearance. Okay, this is one of the physical characteristics. Then you have color. So minerals get the color because of impurities, right? If there are some impurities or because of its own nature, it is going to get some color, right? Color is because of the impurities. Then you have streak. Streak means what? Streak means, see, if you take some mineral, right, proper mineral, the color of the mineral is called as color. But if you break the mineral into powder and you get the powder form, whether the powder is of the same color, suppose you say take some green color mineral, it is in green in color. If you break it, it will become powder. So whether the powder is also green color, right? The color of the powder is the streak. So some mineral, malachite what happens? The mineral color and powder color is same. Whereas in the fluorite, mineral color is pink, whereas powder color is white, right? That is the difference. Then transparency. What is transparency? Transparency means translucent and opaque. So transparency means if a mineral, if you see it like this, can you watch on the other side? That is transparent mineral. Or it is it translucent? Translucent means what? Half visible. That is it is semi-transparent, right? So the light rays, if there is a mineral, the light rays will go within it, but it will get diffused. It will get diffused in all the directions, right? That is the translucent. Then you have opaque mineral. Opaque mineral means iron. So if you take iron, whether you pass the light, it is going to go on the other side? No. So there is opaqueness. Then you have structure of the mineral. What are the structure of the mineral? It is fine. The mineral might be fine structure, or it might be medium or coarse grain. That is grain. Grain means Kannada, what do you say? Kalu. Mineral iro kalugalu tumba sand mineral idya, sand kalu idya. That is fine structure. If it is medium, that is medium structure. If it is coarse means big structure, right? Fine, medium and coarse grain structures, right? Next, then you have hardness. Hardness means resistance of the minerals to scratch, right? So if you take talcum powder, whether is it hard? No, right? So on the hand you have take diamond. Is it hard? Yes, it can cut you. So based on the resistance to scratch, if you scratch on that mineral, whether it is going to scratch the particular mineral, particular object. So the hardness is resistant to scratch. Talc is less scratch worthy. Diamond is highly scratchable, right? It is the scale of 1 to 10. 1 means talc is having the value of hardness 1, means it is not fit for scratching. Whereas you have diamond. Diamond is highly scratchable. Diamond has a scratch worthy of 10. 1 to 10, right? So this is the value. Then you have specific gravity. The concept of specific gravity. So what is specific gravity? This is very, very important. I am going to read you the definition. Specific gravity and relative density both means the same thing. So relative density or specific gravity is the ratio of the density of a substance to the density of the given reference material. Let us say you take the, where is the duster? Okay. Okay. So you have this duster and you have this mobile phone, right? So what is the difference of density, right? So relative density is the ratio of density of a substance. I want to know the density of this substance. So density of a substance to the density of a given reference material. The ratio of this density to this density is called as specific gravity, right? So specific gravity is the ratio of density of one substance to the density of a given reference material, right? Specific gravity for liquids is nearly always measured with respect to water, as it is the densest. Among the liquids, which is the densest liquid, it is actually water. People will actually get confused. Water is the densest liquid. So, here specific water of liquid is always measured with respect to water, as it is the densest. For gases, the reference is air. Air is the reference for gases, right? So, this is with respect to specific gravity. Then you have major minerals. Major minerals you should know. The first major mineral is feldspar. Feldspar consists of silicon and oxygen. Feldspar is made up of silicon and oxygen. Half of the earth's crust, you know what is crust? Half of the earth's crust is made of feldspar, right? So, where is this feldspar used for? Feldspar is used for ceramic and glass making. In the making of ceramic objects and glass, the feldspar is used. Then you have quartz, not the watch company quartz. So, quartz is a mineral. So, it is made up of sand and granite. Quartz is made of sand and granite. So, the major content is silica. Quartz is made up of silica, right? So, it is insoluble in water. Where is quartz used? It is used in your radio. It is used in your radar. Radio and radar, quartz is used. Then you have pyroxene. Where is pyroxene used? So, pyroxene, it consists of, you need not know all these elements, it is difficult. So, I will just say it is made up of calcium, aluminium, magnesium, iron, and just know the constituents of feldspar and quartz, because it is only two constituents. Whereas pyroxene 5 need not know. 10% of the crust is pyroxene, right? So, where is this pyroxene found? It is found in the meteors. You know what is meteors, right? It is there in the meteors. Then you have amphibole. Amphibole also you need not know the elements which are there. 7% of the crust is amphibole, right? It is made up of, where is this amphibole used? Asbestos sheet. In the asbestos sheet, you will find the amphiboles. Next you have mica. Where is mica used? Mica in the potassium. Mica, what all it consists? So you need not know 5 elements, it's difficult to remember, right? So mica, it is used in electrical instrument, right? And also it is made up of it is found in igneous and metamorphic rocks. I will discuss what is igneous, what is metamorphic rock. Then you have olivine. So olivine, what is it made of? It is made of magnesium, iron and silica, not important. Where is olivine used? It is used in jewelry making. Also, it is used in basaltic rocks. So, it is found in basaltic rocks. So, you know what is basaltic rock? Shield volcano. Thin lava is called basalt. Basalt comes out of thin lava, viscous lava. So, that is the basaltic rocks. Then you have metallic minerals. What are the metallic minerals? So, these metallic minerals are precious minerals. Ferrous. Ferrous mineral means what? It consists of iron. Iron is called as what? Ferrum. What is the formula? Fe. So, metallic minerals are precious. They are ferrous. They can be classified into ferrous and non-ferrous. They are precious metals. They can be classified into ferrous minerals and non-ferrous minerals. What are the metallic minerals? You have copper, you have lead, you have zinc. Non-metallic, that is non-ferrous, you have copper, lead and zinc. These are non-ferrous. What are ferrous? Iron, aluminium, all these are ferrous. Non-ferrous is copper, lead and zinc. Please know this one, they will ask you. Which are the non-ferrous minerals? Copper, lead and zinc. So what are the non-metallic minerals? Non-metallic means, non-ferrous means that which does not contain iron. Whereas non-metallic means sulfur, nitrates. Sulfurs and nitrates are the non-metallic minerals. So, you find cement, you have non-metallic components, right? Next you have rocks, the rocks. We will talk about the rocks, different types of rock. Earth, where do you find rocks? You find rocks in the crustal portion. Crust of the earth. So this rock, it is made up of one or more mineral. It consists of one or more minerals, right? So hardest rock is granite. Granite is the hardest rock. Then soft rock is soapstone. Soapstone is the soft rock. So which are the major elements, major minerals found in rock? It is the feldspar and quartz. Feldspar and quartz are the minerals found in the rocks. Feldspar and quartz. So the study of rocks is called as what? Petrology. Very important. Petrology, not petrol. Right? So you have three types of rocks: igneous rock, sedimentary rock, and metamorphic rock. Igneous, sedimentary, and metamorphic rock. So what is igneous rock? This is solidified from the magma and lava. So whatever the magma and lava comes, out of which this igneous rock will get solidified. That is the igneous rock. This is the primary rock. Igneous rock forms the primary of all the rocks. All the rocks are originated from igneous rock. So after this magma and lava cools, then only you will find the igneous rock. Right? So texture. So how will be the texture of the igneous rock? The texture of the igneous rock based on the size and arrangement of grains. So you know, grains means the constituent of rocks. So within the rocks, how the grains are arranged. So based on that, the texture will be dependent. Texture will be dependent on size and arrangement of the grains within the rocks. Then you have within the sedimentary, within the igneous rock, there is slow and deep cooling. So if see, I told you there will be grains. Based on how the grains are arranged, the texture and you know how this rock is. Whether it is porous, whether it is solid, that is the texture. So if the magma cools at a very deep within the earth, or it cools very slowly, then you will form large grains. There will be big grains, right? If the grains cool suddenly, if the grains of the rock cool suddenly, right, there will be small and smooth grains. Sudden cool there will be small size grains or smooth grains. Or if it cools deep, there will be big size grains. That is the difference. Which are the igneous rocks? You have granite. Granite is igneous rock. Gabbro or gabbro, basalt and pegmatite. These are the major igneous rock. Granite, gabbro, basalt and pegmatite. Then you have sedimentary rock. What is sediment? See, igneous means which is formed out of magma or lava. So what is the sedimentary rock? So what happens once this rock come out of the earth? So it will, because of weathering, the rock will break away and it will become small pieces. So these small pieces, they will go and get collected at one place. Because of high pressure and temperature, these rocks will get collected. There will be one process called lithification. So these small segments, because of high temperature and pressure, they will get compressed and they itself will become one rock. Small segments of broken rocks becoming one big rock because of heat and temperature. Heat and pressure is the sedimentary rock, right? So deposition of rocks by exogenous process. Means what? Exogenous process means the rocks, I told you, the rocks, small fragments will get deposited. What is the exogenous process? Means by erosion, by rivers. Rivers will carry these rocks, or by erosion with the sand. These will come and get compacted at one place, right? Denudation into fragments. They will get, rocks first will get denudated into small fragments, then they will get compacted, right? So this process is called compaction. Compaction. Then you have lithification. This process is called as compaction. Out of sea, when the rocks get compact into one big rock, small rock, there will be also minerals in it. There will be what? Thicker rocks, thinner rocks, all these different types of rock material will be there, rock minerals will be there. So there will be what happens, one layer of thick rock, one layer of thin rock, all of them will get compacted and one big rock will form. The layers will be visible. So that is called as lithification. Different layers within a rock, right? Layers of varied thickness is called lithification. What is the example? You have the example of sandstone, shale, limestone. Sandstone, shale, limestone, all of these are the examples of the what? Sedimentary rock. These are mechanically formed. Mechanically formed means they are formed out of temperature and pressure based on the mechanical process, right? So these are mechanically formed. Also they might be organically formed. Organically means what? Because of some living organisms. Living organisms might press the rock, press the fragments of rock, and they might get compacted. Or else there will be some organically means there might be some bigger rock which is falling on the smaller rocks, right? That is one thing that comes under mechanical. Organically means due to some reactions that is there. Also they can be formed because of chemicals, chemical reaction. If the rocks is formed, that can also be a sedimentary rock. These sedimentary rocks are formed under mechanical, organic and chemical. The metamorphic rocks. What are the metamorphic rocks? So existing rocks undergoing recrystallization. Metamorphic rocks. What do you mean by that? The existing rocks undergoing recrystallization. Means what? See, there are two types of rocks I have discussed till now. Igneous rock and sedimentary rock. These two will undergo recrystallization. Means these rocks, in these rocks there will be crystals. Rocks are formed out of crystals. These crystals will undergo recrystallization. Means they will form into, become something new. Recrystal. These crystals will get rearranged. Why do they rearrange? Because of pressure, volume and temperature changes. Because of the pressure and volume and temperature changes, the rocks will undergo recrystallization. That is the existing rocks undergoing recrystallization is the metamorphic process, right? Here you have tectonic. So how do this metamorphic process take place? So I told you it is because of pressure, volume and temperature changes. It might be because of tectonic reasons. What do you mean by tectonic reasons? Tectonic means the earthquake, all these things, earthquake, plate boundary movements. It might be because of that, or it might be because of magma. The metamorphic rocks might be formed because of magma, or it might be formed because of overlying rock. Some overlying rock will be there. Because of that also metamorphosis might happen. Some rock over other rock, right? So if one rock is lying over other rock, what is the change? It is the pressure change, right? Pressure, tectonic, magma and overlying rocks. These three phenomena give rise to metamorphic rocks. So under this there will be mechanical reorganization. Means the crystal will get reorganized among themselves. Crystals of the rocks in the metamorphic process. However, in the metamorphic process, there is no chemical change. Please remember, it is only mechanical change. Whereas here, there is mechanical, chemical and organic under sedimentary. In metamorphic, it is only the mechanical change, no chemical change. Right? Here you have the three, this is, there is a mechanical metamorphosis. Mechanical metamorphosis is there. Then you have chemical metamorphosis is there. and there are two types of metamorphism. One is mechanical and chemical. So under mechanical metamorphosis, there is no chemical change, right? It is purely based on mechanical reasons. Mechanical means because of the pressure, volume or temperature change, or some animal will press the rock, or all these changes, right? There is no chemical change. This is called as dynamic metamorphosis. Mechanical reorganization is also called dynamic metamorphosis. The second form is chemical metamorphosis, chemical alteration. It is also called as thermal alteration, thermal metamorphosis. Because of temperature change, if the metamorphosis happens, it is chemical metamorphosis. Under chemical metamorphosis, you have contact metamorphosis and regional metamorphosis. Contact metamorphosis means what? See, suppose a rock is there. It comes in contact with the magma, hot magma. Because of the contact of hot magma, the rock will change. That is contact metamorphosis. The rock changing because of coming in contact with the magma. It is contact metamorphosis. Then you have regional metamorphosis. What are these? Contact and regional both come under what? They come under chemical metamorphosis. So what is regional metamorphosis? In a region, in a particular region, if a change takes place, if an earthquake happens, if a landslide happens, if the rocks change because of that, that is what? Regional metamorphosis. That is because of tectonic shearing, tectonic changes, right? Then you have in the metamorphic rocks, the rocks, within the rocks there will be grains in this order. They will be arranged in this order, this or some order, right? Layered or linear arrangement of grains. Layered arrangement of grains or linear arrangement of grains will be there. So that is called as foliation or lineation. The arrangement of grains within the rock is called as foliation or lineation. Please remember this. Then you have banding. Banding means thin and thick layers of rock coming together. Thin and thick layers of rock coming together within a rock is called as banding. Banding and foliation is very, very important. Foliation means arranging of the grains. Banding means thin and thick layers coming within a rock, right? Then there are two groups. Two groups within the metamorphic rocks. One is foliated and non-foliated rocks. Foliated rocks means those which are arranged. Non-foliated means those which are not arranged, right? So, slate, marble, quartzite are the examples of metamorphic rocks. What are the examples? Slate, marble and quartz. See, granite is a igneous rock. Marble is a metamorphic rock. This will be the example because granite and marble you will be knowing while constructing houses, right? But which is what rock you would not be knowing. So there are two groups, foliated and non-foliated. These are the examples. This is with respect to three types of rocks. So rock cycle is very important. What is rock cycle? Transformation of the old rock into new rock. Old rock into new rock is the rock cycle. It is a continuous process. So what is the rock cycle? So first you have magma. So from the magma gets solidified and forms into, see, please look at this diagram, it's very important. So magma will get solidified into igneous rock. This igneous rock again can melt and become a magma. This is the first cycle, right? Then or this igneous rock can, because of pressure, volume and temperature change, it can directly become a metamorphic rock. This is, and from there it can become magma again. That is the second cycle. Or this igneous rock, because of weathering and erosion. Weathering is rock breaking. It can become a sediment. Sediment means small rocks. And those rocks coming together is lithification. Lithification can happen and it can become a sedimentary rock. Right? From the sedimentary rock, again, metamorphic rock can happen, or sedimentary rock directly can become a magma. Right? Or this sedimentary can break into sediments again. Sedimentary rock can break and become sediments again. And again, this metamorphic rock also can break and become the sediments. But metamorphic rock cannot become an igneous rock directly. So, are you getting the difference? So, this rock cycle of all the cycles is very, very important. Right? Please know about the rock cycle. Okay. Then, geomorphic processes. So, what is geomorphic processes? So, earlier crust, Earth's crust are in the earlier times used to move in a very fast manner. Now it is not moving in such a fast way. Like in the earlier times, it is not moving now, right? So there are two types of geomorphic processes. One is geomorphic means what? The formation of earth. Geo means what? Earth. Earth forming processes are called geomorphic process. So there are two kinds of forces. One is exogenic force. Exogenic means the forces outside the earth are called exogenic forces. What are exogenic? You have degradation. You have a rock. Suppose you have a fossil or rock. If it gets degraded, if you have a wood, if it gets degraded, that is the first process. Or if there is a elevation. Elevation means, degradation means bigger body becoming smaller body, bigger rock. Whereas elevation means there will be a building of rock. There will be nothing there. In that Kali place, there will be a building of rock. New rock will come up. That is elevation. Or there is depression. Depression means if there is something was there, that will be removed and a hollow will become. So these three can become out of exogenic process. Then you have gradation. Gradation means land. If there is a land, if it is worn down, means what? See, it's just like this. How do I explain? So suppose there were too many mountains. All the mountains will become clear and it will become a plain land over a period of time. That is gradation. Land getting wearing down, right? Land will slowly getting worn down and later on it will become a plain land. That is gradation. So then you have the endogenic forces. Endogenic forces means forces within the earth. Forces originating within the earth are called endogenic forces. So what do? They do elevation. They elevate the earth or they build new rocks. That is the endogenic forces. These are called land building forces. Endogenic forces are called land building forces. So these are the two interventions for changes on the surface of the earth. The third change is human intervention. Humans are doing mining. They are doing deforestation. They are changing the landscape. They are doing pollution. Because of human induced changes are also important for the changes on the earth. Geomorphic process, human intervention is also there. Three reasons. Then you have geomorphic processes, endogenic. So under endogenic process, you have diastrophism and volcanism. Diastrophism and volcanism. What is diastrophism? What is volcanism? I will discuss. Then you have under exogenic process, you have weathering. Weathering, mass wasting and erosion. Means something which happens outside the earth. Weathering. Weathering means rock weathering and becoming soil is weathering. And mass wasting, we will discuss what is mass wasting. Third is erosion. Erosion of the erosion of the weathered material. These are the three exogenic forces. Then you have physical and chemical changes. So on the earth there might be physical changes also or chemical changes also. Both these changes can happen, right? What are the exogenic elements? What are the elements which carry out the exogenic transformation? It is water. Water might carry out the exogenic process. Water might, see, if there is a river, river can do what? It can worn down or gradate a rock, right? River can break a rock over a period of continuous movement. Or there might be ice. Ice can be an element. Wind can break a rock. So all these are called as geomorphic agents. Water, ice, wind, all these things. So then you have gradient and mobility. What is gradient and mobility? See, gradient means there are Gradient means it is a change from one level to another level. There is temperature gradient, there is height gradient. See, suppose one level is here, another level is here, land. So the rock will fall from here to here, right? Or water will flow from here to here, right? This is called as gradient, height gradient. Then you have temperature gradient. Change in temperature is temperature gradient, right? Temperature gradient is there. That is one process. On the hill there is low temperature, below there is high temperature. The change between these two is called temperature gradient, right? So gradient is also responsible for geomorphic processes. Then you have mobility. Mobility means on the earth there is lot of mobility. Water moves, wind moves. All these are responsible for geomorphic processes. Then you have gravity. Gravity is a directional force. Directional force means it is, what is the direction of gravity? Down. So that will also be responsible for the geomorphic processes. That is earth changing processes. Gravity is also responsible. Then you have endogenic processes. Endogenic means within the earth. What are the endogenic processes? Within the earth, what is responsible? Energy from radioactivity. You have energy from radioactivity, and you have energy from rotation of the earth. If you have energy, see, endogenic process, where does the energy come from? For changes within the earth. One is radioactivity, and the second one is rotation of the earth, and the third one is tidal energy. Tidal energy will also lead to endogenic changes, right? Then you have geothermal gradient. Geothermal gradient. What is geothermal gradient? Means there is a change in temperature between in the earth. See, within the earth there is, if the temperature here is 1, the temperature within will be different. So there is a change in temperature level. That is geothermal gradient, change in the earth's temperature, right? That is also responsible for an endogenic process. Endogenic changes within the earth. Geothermal gradient is also responsible. Then you have diastropism and volcanism. See, diastropism, it means a earth building process or a continent building process. Diastropism means earth building process. You can consider like how the mountains or the earth is formed is diastropism, right? Diastropism and volcanism in the lithosphere, both of these are responsible for endogenic processes, the processes within the earth, right? Okay. Next, diastropism, these what does it do? It elevates and builds the crust. I told you, earth building process. It elevates the crust and builds the crust. That is the diastropism, right? So, orogenic process. What is under diastropism? There are two processes, orogeny, epirogeny. What is orogeny? When the crust, orogenic process, it is a, you can call it as a mountain building process. When mountains are built, it is a orogenic process. How does the orogenic process happen? The crust gets deformed into multiple folds. Earth's crust will be there, no? It will become multiple folds. If it is like this, it will become into multiple folds. That is the orogenic process. Eporogenic process. Eporogenic process means continental building process. See, orogeny, mountain builds. Eporogeny means what? Continental building process, right? That which builds the continent. So you have the earthquakes. Earthquakes are also responsible for orogeny and eporogeny. Because of earthquake also land will be formed, right? So you have plate tectonics. Because of plate tectonic also, see, earthquake is also called as diastropism because it elevates and builds the crust. And plate tectonics can also be called as diastropism because it elevates and builds the crust. I told you, plate tectonics, crushing, divergent, convergence, transform, crust will be deformed, right? That is diastropism. Then pressure, volume and temperature changes. pressure, volume and temperature changes, that will also lead to crust changing in crust, and also metamorphism. Metamorphism will also lead to change in the earth's crust. So these are all diastopism. Then you have volcanism. So volcanism leads to both intrusive and extrusive forms. Means it can build to earth with, it can be a intrusive process also, because what? See, volcano magma comes from within the earth. That is why it is an intrusive process. Whereas the volcano, the magma spills outside. So that is why it is an extrusive process. Volcanism will also lead to change in earth because of intrusive and extrusive process. So this is about the endogenic processes, right? Then what are the exogenic processes? Exogenic processes. So exogenic processes, energy from the atmosphere and sun. So exogenic means changes from outside the earth. So where do the energy comes for the changes outside the earth? You have energy from atmosphere, right? Energy from the sun. These two are the energy from the sun, and the atmosphere is the energies, and also you have energy from gradients. Gradients means, so I told you, temperature gradient, height gradient, pressure gradient, all because of that also energy will be there for exogenic change on the outside of the earth. So what are the energies? These are the energies. So gravitation is also an energy. Gravitation is a downslope force. Gravitation pulls all the elements downward, right? So that is also a force for exogenic. It is a downslope force. So forces acting along the faces of the earth material. Shear stress. What is shear stress? See, there will be, because of this exogenic process, what happens? There will be lot of pressure. There will be lot of stress on the objects because of external elements. So when there is, suppose, let's say here is a rock. Above that rock you place one rock. So what happens? There will be lot of stress. Because of the stress, there will be pushing. Something will be pushing that rock, right? And from the below, gravity will be pulling. So there will be pushing force also and pulling force also for the same object. That is the shear stress. Shear stress is a exogenic process. That is forces acting along the faces of earth material, along the rocks. If the forces happen and the forces lead to shear and stress, or pull and push, it will lead to shear stressing. That is an exogenic process. It will do what? It will break the rock. That is one form of exogenic process. Then you have molecular stress. Stress in the molecules of the rock. So why do stress in the molecule of the rock? Because of temperature change. Because there is a change in the temperature of the rock. That will lead to molecular stress. Crystallization, because of there will be different crystallization. If a rocks undergo different crystallization, crystal gets changed within the rock. That will also lead to molecular stress, and also melting of rock. Melting of a individual rock will also lead to molecular stress, right? So not only molecular stress, there will be chemical process. Chemical processes, loose bond. See, in the rocks there will be some rocks there will be loose bonds among the material. So these loose bonds will get dissolved and the rocks will break, right? That is the chemical processes. Loose bonds will get dissolved. So molecular stress because of temperature, crystallization and melting. Chemical process because of the bond dissolving. Then you have denudation. Denudation, I have already told you. Denudation of the earth. Earth, rock, clearing and becoming a plain land, right? So weathering, what are the forms of denudation? Weathering, mass wasting, erosion. Weathering is big rock breaking into soil is weathering. Mass wasting is for example, landslide, rock slide, all these are avalanche, all these are mass wasting. Then erosion. Erosion, you know, from one place to another place, if the rock is sand is moved or the mud is moved, that is erosion, right? So these vary from region to region. This denudation varies from region to region because the pressure, volume and temperature changes from region to region. Denudation varies from region to region. Because why? Because climatic or other reasons. From region to region, climate and other things change, because of which denudation will also vary across the region. Also, this denudation depends on the structure of the rocks. What is the structure of the rock? That will also determine the denudation. Right? So, it also depends on the structure of the rocks, denudation. So, this resistance to change, so I told you, because of exogenic forces, there will be lot of stress on the rocks. But certain rocks will resist the change. They don't want to change. So, there will be resistance from the rock side also. Rocks will also resist the changes, that you should know. So, these exogenic forces, these are imperceptible in the short span. That is, the wind, water or the avalanche, whatever the change it does, you cannot notice it in the short time, 1 year or 2 years. Over 100 years, if you notice, you will notice that there was a rock here, it is disappeared because of the denudation process, right? So, this is the exogenic process, right? Tomorrow, we will continue with the most important concept of weathering, right? Weathering, we will continue tomorrow. So, if you have any doubts, please put it in the comment section. You can reach us on the VHS Education Forum for any doubt clearing and mentoring for any competitive exams. And please make good use of the classes. And if you have any suggestions about the quality of the classes, improvement in teaching techniques, please do give us feedback, because we grow with feedback. Please take good care of your health. Jai Hind. Namaste.